Hey, now that you're a super pro at drawing atomic orbital crazy balloon diagram things, and well, you got a decent hang of the different shapes S, P, D, and F. Now we need to get into like how we formally organize that, which I know sucks the life right out of the room. So we call these electron configurations is the way that we formally do that. But that's the last time you ever want to write that. Okay, so we usually just shorten this up and call it econfig. All right. Hey, welcome to econfig. All right. So big picture. Here's the whole point of this guy. Electron configurations are about showing the location of every electron in each occupied suborbital. Okay. Now, because it says every, which I know gives you the good feels, this one is referring to the complete electron configuration. There's another one that we'll preview, but the ending of the econfig is enough to determine which the element is. Okay, so even though we started getting good at reading the code for how the orbitals work, we're going to start to poke holes in some of our assumptions, and then we're going to come back and make some official rules for how electron configurations work. Okay, so before we do that, let's go drift over here. Hey, look, a periodic table. Okay, so this is actually the same one that you have probably buried in your backpack, hopefully. Okay, so here's a few fun things about this and the goofiness of how it's organized and all that kind of stuff. Okay, let's make this a little thick here. Okay, so one of the main reasons for why this is organized so funkily, like you have the skinny tower on the left, the drop down valley, and then the mesa up on the right, and then for whatever reason the two strips pulled out down on the bottom. Remember, these are the homes for each of the types of orbitals. When you're going down the left on the side, so just giving you a quick review here, so I'm pretty sure we covered this. All right, so the pels are the numbers on the left, so we call that pel 1, pel 2, all the way down to pel 7. If you notice down on the bottom, those two strips don't have pels, and there's a real good reason for that. But, alright, so recall, this is the S block. Going across to the far right, we got the P block. Cool. Drop down section in the middle is the D block. And finally on the bottom we got these two strips, and these are the F block. Okay. Next, we're going to make a super nice color-coded one here. I'm sure you already got excuse me, some interesting draft version of that going, but this is just super loose for what we got right now. Okay, so I know we did a few things with this last time, and just to bring us back into it, hey, for example, if I were to say 1s2, 2s2, 2p4, so this is the electron configuration. This belongs to a specific element, or at least a specific set of electrons. Remember, kind of assuming everybody's neutral here. So if you count up the exponents, and you say 2, 4, 8, that's enough for you to be like, oh, okay, yeah, this guy is oxygen, right? So we did that previously. So if I'm a little more withholding, what's that like? And just say, well, hey, we're going to go to 3p2. That still should be enough for you to find it. So notice there's like, well, hey, let's try to find it first. So a few notes. Remember, so this says the pel you're on. So we're going to go down to the pel 3. So you count down the left. Okay, pel 3. your answer is somewhere in that row. This says zip over to the P block. Okay, so that means your answer is one of these 6 now. And then lastly, this tells you how many electrons are in it. That's the same as the spot it is in. So in this case, your answer for sp2 would be silicon. Okay, so it's kind of weird to kind of say like, okay, sure, all this suborbital business that gets you to the end is important, because the job of the electron configuration is for you to completely show every single electron and where they are, and the proper order and progression of suborbitals, as if you were building the thing from scratch. It's one of the rules we're going to pick up. Okay, but that is super uber crazy tedious, and even if I give you something like in the 30s, it feels cruel because it takes so long. So, in all truth, the ending is enough to take you to where you're at. So just a couple more for you to practice. I know we did some versions of these, but it's nice to have these in the front of your brain. So I'm just going to kind of jump us around randomishly. So go ahead and hunt down a 5s2. Oh wait, let me do some magic here. There we go. All right. So just as a little wake-up mode, go ahead and try those other 2. I guess we can call this B, C, and D. Feel free to pause and make your guesses if you would like. I got nowhere to go. Oh, wait. All right, I'm bored. So 5s2 means Pell 5. Your answer is in this row. Okay. S block, your answer is one of these 2. It's kind of nice already zooming in there. All right, 5s2, you're the second slot. Hey, you are strontium, guy. Nice. Okay, 4d6. All right, Pell 4 is right here. 4d6. That's a 7. 1, 2, 3, 4, 5, 6, 7. Okay, so our answer is in this column here. But here's the goofy part. I know you want to say it's cobalt, but it's not. Your answer is rhodium. What? I know. Okay. Bite down the frustration. Okay. There's a reason for that, which is what we're going to cut back to in just a second. Okay, 4F3. Now, I know that just torpedoed your confidence, but I know you can go, hey, okay, F block. I know where I'm looking at least. F3s, that's one of you 2. And then the crippling, racking doubt settles in. Okay, as it happens, okay, don't make it a 50-50. Your answer... yeah, I can't really handle the suspense here. Hey, it's praseodymium. Cool. Okay. Meaning, even though they are free-floating off in their own space territory, this is a Pell 4. This is Pell 5 down here. Which is even more insane to think of, because these guys, the lanthanide series, plugs in here, which is really on Pell 6. Okay, so does that mean these F blocks are really Pell 6 and we're just, living a lie? And then for that matter, why then by that logic, so if we said rhodium was in 4D, so why are these 3Ds amongst the 4th Pell? Right, so even though we have enough for the patterns, our patterns fail when there's things that are exceptions. Certain things just seem atypical to what you'd expect. So let's return to the norm, and we got to add some structure to our econfigs. Okay, so what we thought was going to be getting away with something very easy, zooming through to the fast forward ending where you know the answer, and then just fillering everything in before that. That's totally cool if you have something to copy and paste of. We will not. So to be able to do your complete Electron configuration, we need some rules for this to be able to handle it. So let's jump in here. So I'm going to treat this kind of like its own title. Rules for econfigs. Okay. Rules, guidelines, we can be a little loose with the definition. Okay, first you got to practice your German. First rule is the verb in German for to build up. So it is Aufbau. So to build up. Okay, especially if I said, hey, Aufbau, to build up. Kind of made a lot more sense when we were drawing our crazy atomic orbitals up from nothing. But same thing, 1s2, 2s2, you're always going to start every stupid one with 1s. It's all about building from the ground up. Now when I say we build from 1s to 2s, okay, the truth of that statement is lower energy orbitals fill first. So, just because we always test out the logic on these. So, that means a 1s is always lower energy than a 2s. So you'll always fill the 1s first. Totally true. Okay. But then if you remember how s's and p's compare, s is a nice smooth simple shape, p's start to pick up some pace. So s's should generally fill before p's. Okay. But when we start to mix things up, like if I say, okay, what about 2p versus a 3s? So now we have this dilemma where we're kind of juggling what we know about the Pels versus each other against opposite factors of dealing with these suborbitals. So it's tough when you're trying to deal with two competing balances, because you could kind of say, well, 3s wins on the Pel, but 2p wins on the suborbital shapes. So it's a tie? Coincidentally in this case, 2p is first before 3s. So does that mean the 2's always win? Maybe, maybe not. But let me show you one that will hurt your brain. Okay, just as an example. So scandium, if we fast forward to scandium, here we go. I'm not going to make you suffer through it. All right, take a look. So this guy, so if you notice the patterns, there's the 1s before the 2s, 2p coming before the 3s, just like we settled, and then it looks like the p's are all bigger than their s's, and then this junk shows up and kind of messes up our game. Because you're like, whoa, 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 I'm on a Pel 4, and that's happening before a Pel 3. And you literally just made me write down lower energy orbitals fill first. Okay, so here's the weird part. D with our crazy four-leaf clover butterfly shapes. Empirically, if this is the correct order, then we must assume that 4s is lower energy than 3d, which is true. But now it starts to feel like we're splitting hairs, and if there's exceptions and all these kinds of things. So there is a system to remember that kind of stuff. So the system I'm going to give you is one that I have seen unofficially in a couple Google searches. I know I've had some really old Vanguard professors give me alternate versions of this that were not terribly helpful. But we're going to use the Aufbau principle as a tool to tell us the order. So we have this thing called the Aufbau tower, or that's what I'm calling it. I would go over here and make a note for Aufbau 2. The whole point and purpose of it is to give you order. I'm not just saying like rule of law order, but an order to these orbitals. Okay, here we go. So, first, we have a total of 7 Pels. Sorry, you're going to cope with my handwriting on this. Okay. And Another video is almost out. Go look at the next one.